Hello everyone. Today we will continue talking about some BGP stuff. Yesterday I was given a presentation about best current practice in BGP and state for BGP security. So today we will not touch this sphere, but we will move to some more interesting topics, namely BGP connectivity. And we will not talk about global connectivity and so on, but we will dive into some specific features that are specific for Czech Republic, Slovakia, and so on. Second. Okay, and after giving yesterday's presentation, I wasn't fired during the last day, so I'm still working at the Curator Labs, and I'm still analyzing BGP security issues. And we are analyzing them by studying BGP routes that are collected by our own BGP collector. And actually, we are having also points of presence, not points of presence, but BGP sessions in Czech Republic. But there are too few of them, and we will be happy if you will provide us with more data. While we are talking about it, we will talk about a state of internet connectivity and so on based on this BGP data that was collected by this BGP collector. So if you want to reproduce this measurements, you will give a slightly different numbers, but the main trends will remain the same. And what we will cover today. First of all, we want to look at global position of Czech Republic and Slovakia in comparison with other countries. Also, we will dive into country connectivity, look at big players, and so on. And after it, we will study an internet security part of connectivity, and so we will talk about an outage possibility of a region, and so on. But first thing first. How we can understand that this particular ISP are belonging to a particular country? First of all, you can just ask a specific reader. For example, in our region, it's RIPE, and ask him who are these particular ISP are belonging to. And there are two main ways to get this information. Just downloading a RIPE file from the FTP server, and this RIPE file also provided you with official ISN name description, or by using a API, and this API will provide you with the list of all the needed numbers. But if you don't think that giving a map from ISN to country is sufficient enough for you, you can just analyze the prefixes that are announced by this particular ISP, and then map them with some database. And you can just make the equal weight for all the IP in these prefixes, or just look on only on live IP, on PTA records, and so on, if you want to get a more exact measurement. But for our cases, we will use the first one, we will use RIPE file, and the difference between these methods is too insignificant. So let's move to the most simple kind of measurement, the actual number of ISPs. And we can just look at the number of register ones, or take a look at routing tables all around the world and find the active ones. And actually, even by looking at these nominal numbers, we can see some interesting trends. First of all, we can see that in IPv6 and that IPv6 has a great spread in all around two countries, and especially in the Z. Also, we can see that even more than half of ISP are dual, and if we remember the yesterday and today presentation, if we are speaking about modern services, they are providing the IP address in both spaces simultaneously. And there are even some ISPs that place their resource only in IPv6 space that are really amusing me. And if we are to take a look at the row, place is a place of this particular country in this address space compared to the other nations and other countries in the world. But let's move to the prefixes. And we can speak about IP addresses, the number of IP addresses, but in IPv6 it's a meaningless kind of measurement. In IPv4 it has some meaning, but there is no such big amount of prefix length distribution in these countries. So talking about prefixes will be enough. And actually the most common case is an ISP that are announcing only one prefix. And this is understandable. But more interesting is that the biggest ones of ISPs are not deaggregated the address space and announce only aggregate ones. And by looking at the fraction of prefixes to a sense, we can see that it's an uncommon situation, and these countries are even in the 300 by this metric. And it's pretty interesting. But let's stop talking about nations and let's talking about a particular ISPs. And there are what we want to find. We want to find an average profile. We want to find a big players, a good ones, and understand how these big and good ones of ISPs can influence on a completely regional structure. And as I was mentioned before, we will talk about a bigger ISPs in terms of BGP connectivity. And the most simple one is to use as a metric a number of customers or other operators that you provide a transit. And it will be not trustfully if we don't take into account also a customer of customers, customer of customers of customers, and so on. So also we will take a look at a customer con. And if there is no other option in a particular region or for some operators, then they must choose this particular SP, and we will see that this is also a case in some type of situations. So who are the big guys? First of all, we can see that in the last row that there is one operator that have in their customer con nearly all of the active ISPs. And we will describe why this kind of situation appear. And also we can see that in the previous row there is one operator that have a much greater connectivity in IPv6 space than in IPv4. I hope you understand which this sense map to which operators this sense map to, but I will help you. So the biggest operator for Czech Republic is UPC, and it's understandable because it's the largest broadband company. Also, the next guy make my day because they have a really awesome name and even more awesome whois record. And also the peer-to-peer largest CDN provider. Also there is T-Mobile, and even looking at the previous table, we can see that this way to find out a biggest transit have some lack of trustfulness, because we are looking at biggest transits in terms of operator of network connectivity, and we don't look at traffic at all. This is why we don't see SysNAM in these tables, and we will not see them even further, because it's a larger CDN, but not great in terms of networking. So let's go to the next slide, and we will see that the same two operators, Hurricane Electric and Telia, are also present in it. But more interesting, there is a company in last row that have only 2 customers but have a great customer con. Why this happened? First of all, the biggest transit provider in Slovakia is Benestri and Slovak Telecom, and they both are part of Deutsche Telekom family. So it's now understandable why DTAC have this great customer con, even if it have as customer Slovak the previous tools. And Binestra is the biggest broadband, and Slovak Telecom carried all type of services to the country. But let's take a closer look at Tele, Freecon Electric, and other Tier 1s. Who the hell are Tier 1s? Tier 1s is a transnational operator that own magistrals placed all over the world and don't have any other providers upper than them. And if we want to understand the global connectivity, we must to look at connectivity between local Tier 1s or big regional transits and between Tier 1 operators. And if we take a look, the blue ones is national transit operators, Hexagon is Tier 1s, and we see that there is a great connectivity between them. There are a lot of operators on the border, and let's dive into even more details. So, if we remember Hurricane Electric have a lot of local customers, and we can actually see it on the picture. Also, we can see that DTAC actually have two main customers, and so on. So on the borders, the connectivity is really great. And also I want to mention that the customer con are not a best metric for Tier 1s, because most of the big transit are connected directly to them, and the customer con of these operators are the union of the customer cons of these transit providers. So for them, we must look on local customers and so on. But let's stop talking about big ones and let's talk about average one operators. And most operators in any country don't provide any transit to others. They just want to buy a transit from one or two providers. And in first case, they are calling stubs, and they have no redundancy at all. And in other cases, they are multi-homed. And what's the average profile in the Czech Republic and Slovakia? I want to mention the difference. First of all, I want to mention a difference between two last rows. Stub is an operator that have only one provider, and clear stub have one provider and haven't any present on the local exchanges, doesn't have any peerings, and so on. So if you are stub but not clear stub, you want to have a regional connectivity and good presence in the region. But in the case of clear stub, you just want to have some point of presence to the internet, and you doesn't get damn about anything else. And if we look at the fractions, they're pretty standard to all other countries. So there is nothing interesting in here, except one case is that if we look at the main stub providers, we can see that the known names already to us, and the super network have as somehow place all the stubs or place all the customers on the peering CZ, so they have many peering relations between them. But the three numbers of these four are well known for us, but we don't match with the last one before. Who the hell are them? And when we try to understand who they are, we discover some interesting case, because this ISN is ISP alliance, and it's an alliance of very small operators. What's the problem with them? They're too small to have a good connectivity and to discuss the partnership with Tier 1 operators, with XP and so on. But as an alliance, they can make to start this type of discussions. And this ISN has a connectivity with Cogent, Telia, GTT, and so on. So by making this kind of union, they get a much better connectivity, but in comparison with what they can get by themselves. And it's a very interesting practice for me because I doesn't met with this kind of situation before. It seems like AX, but this AX have also a great have a very great providers to them. So I really hope that this practice will be taken into account in other countries, and if you are small enough, it's maybe a great possibility for you to overcome this limitation. Okay, we were talking about big guys. Who are the good guys? Good guys are the sense that were thinking about their connectivity, and they don't want to be outdated if one of the providers will be turned off. So if you want to have a global connectivity, you will have multiple providers. If you want to have a local connectivity, you will have a lot of peerings. But what's the problem with peerings? As I was said before, we are analyzing BGP routes. And in BGP routes, you can see peering relations if you are in customer con one of these operators. So you must be presented in the region. And as I was saying before, we are not. So we are trying to understand the peering relations not by looking at BGP routes, but looking on the members of the most well-sized IXs. Who these IXs are? It's well known for you that there are two main IXs in CZ and SK, and it's really interesting for me, and I don't have an answer yet, that the most part of your ISPs are presented only on one of these IXs. So I really hope to find an answer to this kind of situation. Hurricane Electric is also trying to be good in this, and he is not having only a good connectivity in IPv6, but presented on all of them. And most of big transit are presented on these IXs, so the overall regional connectivity is really good. But what about global connectivity? If we are talking about global connectivity, the main question is can the users from other countries reach you, if it's really important for you? And how we can study this type of question? We can use a well-known Gaur-Export model and the sufficient limitation or sufficient limitation to reach. It will be can you reach every one of tier 1 operators? If you can reach all of them, okay, you will have a global connectivity. If not, there are some problems with you. And first of all, why we are studying this problem? Every ISP can fail, and if you remember, even the big one can fall into this category. You can remember at December of the last year, the situation with CenturyLink. And if there are no other alternative paths for you, it will result in DOS. And local peering will help you with a regional connectivity because you can transfer your traffic via this peering relationship, but will not help with a global one. And if there is such an important ISP for you, it's a critical one, and we will try to count the ISP who is a most critical one to the most number of operators. And if we look on the other countries, we will see that the most common case is one government operator that are stayed on a national border, and if it's going down, it will result in an outage of this whole country. But we have already seen on a graph that it's not a case for these particular countries. So who will be the critical one for them? And I think you found out that we have matched with this ISNs before. And yes, they are a main star provider for these particular countries. And if you are thinking for a minute or two, you understand that, yeah, who else? But the most interesting part of the situation is that the Binestra has only one provider, and it's a critical one for a SK. Maybe it's not a good case. And if you look at the numbers, it will result in a great outage. And maybe we can think about this and we'll counter the risks again. And maybe we will change the situation to something more better. But this metric is based on assumptions that all ascents have the equal weight to all of them. But we remember that there are some ascents that provided a last mile or have a great amount of end users. And we saying that this ISN is equal to ISN of a university, ISN of bank, and so on. Maybe it's not the right way, and we must look at some other kind of metric. And there is one, and we can look on a number of IP address space that will go down if this particular ISP will be turned off. And if we look exactly on this metric, we will find out that yes, there will be another critical point as O2 Telefonica and Slovak Telecom. And it's understandable because they are broadband and they're most known kind of ISNs that provide a service to end users. And this result may be even more plausible than the last one when we are talking in terms of network connectivity. And I'm limited in a time slot that was given for me, so if you needed even more details or have some quick questions, you can step up to the microphone. So that's all. Up.
Eugen, can you switch to previous slide with weighted address space? Yeah, 41%. 41%. This resembles me to one of the Middle Asian countries with oppressive regimes, and it seems like monopoly is just as bad for internet connectivity as oppressive regimes. Thank you.
All right. Any other question? Anything on Slido? Oh, speak.
Yeah, okay, now I don't have to switch the mic. That's good. I would like only to mention that NASN is just a number saying completely nothing about the network and its internal structure. Yeah, okay. So I would like to say that NASN is just a number saying nothing about the internal structure of the network, about the redundancy, about number of interconnections between two ASNs. Yeah, you can see just one path, then can be 10 paths or 2 paths or any number. Mm-hmm. So having just one path in BGP table through another ASN doesn't mean it's not redundant at all. Yeah. So I think it's good to take into account this thing. Mm-hmm. If you are making some assumptions regarding stability or reliability of a connection. That's all I would like to say.
Okay.
Okay, I don't see any other comments or questions. So thank you very much.
Mm-hmm.